Hey guys, I am going to do the following example and hopefully this is going to get you off to a good start with solving trigonometric equations that are in the style of a quadratic type. So prior to this, we've been going over a lot of factoring, especially surrounding quadratics and those whose leading coefficient a was a number other than 1. I went over using the AC method and grouping to do these. And if you need more help with factoring, please make sure you watch those videos or go for extra help, come for extra help, whatever you need to do. But you really want to make sure that that is not a concern, that is basically something that requires none of your mental attention, because as you'll see, these examples get more complicated. I'm going to record at least 2 other examples today, one of which we will have to do some work with identities, Pythagorean identities, in order to make sure that the trigonometric equation is all of one trig function before we solve by factoring. And the other one will require us to square both sides of the equation so that we can turn it into a quadratic type. You're going to have to remember rules for squaring non-monomials, something that's like 2 expressions or the sum or difference of 2 or 3 expressions, and that you have to expand properly, so on and so forth. But let's get this one started. So the directions say, solve the following trigonometric equation. And then you always want to completely read the directions. As we spoke about previously, sometimes it will be a trig identity, and your job is to prove that the left equals the right. In this case, it's an equation and you're being asked to solve, not verify or prove. Also, the directions go on to say, such that theta is between 0 and 2 pi. That tells us a few things. That tells us that we likely have a finite number of answers, which means not infinite, that it is countable. And it also tells us that we should be using radians to describe our answers, not degrees. If this said between 0 degrees and 360 degrees, that would be different. This is written in inequality notation, and we're going to see an example, one of the next 2, and I will write those out in interval notation. Hint, you're not always given a hint either. Obviously, while we're learning and practicing and seeing things for the first time, excuse me, we will give you a hint in the beginning, just to kind of steer you in the right direction. And remember, this hint will likely apply in anything else that has the same characteristics as this trig equation. All right, hint, recognize that this equation is a quadratic type. Use factoring to solve, which I already spoke about with you. Now, when you're looking at this over here, if you wanted on the side, completely not necessary, but I will do this on the side. You can think of this as 2x squared minus 3x plus 1 equals 0. Now, if you learn to factor the way I learned to factor, or if you just really understand factoring, you might be able to do this in your head. You know that first times first has to equal 2x squared. You know last times last has to equal 1. Since 2 is prime, in fact, the only even prime number is 2, we will use 2x and x. It's possible, though, that this isn't factorable. You don't want to assume that it is, so just watch out for that. From here, 1 is neither prime nor composite, because a prime number has 2 distinct factors, 1 and itself. Since 1 is 1, those aren't distinct. 1 times 1, therefore 1 is not prime nor composite. But I have to use 1 and 1. I need the last times last to be positive, which tells me that both signs inside of each of these factors are going to be the same, either a positive positive or negative negative. Since the outer and inner combine to give me a negative, that means that they're both negative. Then I check to make sure. Outer is negative 2x, inner is negative 1x. If I add negative 2x and negative 1x, I do in fact get negative 3x. However, not everyone feels confident doing that. If you do, amazing, bravo, high five, go for it. If not, Don't get it wrong on an account of, laziness. Just do it the long way until you get it. It'll pay off, okay? So if I were to do the AC method, remember, A is 2, B is -3, C is 1. AC means we're going to multiply A times C. In this case, 2 times 1, which is 2. You make your list of factors. Here, well, 1 and 2 are the only factors. B for bottom of the list, B for but. But what? But I need these numbers to multiply to give me 2, positive 2, but also I need them to add to give me -3. Then you figure out the signs, S-I-G-N-S. -1 and -2 will work out. Multiply, +2, add them together, -3, all good. Then I use those two numbers to split up my middle term. 2x squared minus 1x minus 2x plus 1. And again, it equals 0, so we don't want to lose our equal sign ever. If it was an expression that we were only factoring, don't randomly put an equal sign in there. If it was an equation that we're solving, keep your equal sign there. Just be consistent. Now I'm going to factor by grouping. First group, second group. Greatest common factor here is x. Greatest common factor here is -1. You need more explanation, please check out the factoring videos. Reduce this, I'm left with 2x minus 1. This is already going into quite a bit of detail. Reduce over here, 2x minus 1 as well. Factor out my greatest common factor, which is 2x minus 1. If I pull that out front, what's left inside? Just x minus 1. And then we use zero product property and solve from there. So whatever method you need to use to get it factored, whether you want to do it on the side with x, or if you're comfortable doing that with sine theta the whole time, all good. Another thing, I'm just going to put a little star right here. And along with that star, let's put a little note on the side. That sine, I've gone over this, but can never address it too many times. Sine squared theta really means the sine of theta quantity squared. So that's why when we're doing the problem over there, we can kind of think of it as being let x equals sine theta. I know sine is y in the unit circle. I'm just using x as an arbitrary variable. That doesn't really matter as it relates to this problem, okay? You can use the first letter of your name. I just try to avoid letters like T or even S or anything that could look like a number, Z, just because it gets confusing. So if I carry on from there, my factored form looks like this. So 2 sine theta minus 1 and sine theta minus 1 equals 0. Now, what we use next is the zero product property. You're only allowed to use that when you have a factored equation set equal to 0, hence the name zero product property. Each piece of the product can or will equal 0, so carry on from there. 2 sine theta minus 1 is 0, and sine theta minus 1 equals 0. I'm just showing all the work for this. You may be able to skip a few steps, but don't try to be a hero skipping steps and then mess up and think like, oh, it's -1 on the other side. You're not just picking it up and putting it down. You are using algebra to get your expressions to the other side. Remember, our goal here in this part of the work is to isolate theta. Before you could isolate theta, you have to isolate sine of theta. All right. So from here, 2 sine theta is equal to 1. Here, we're a little further along. Sine theta equals 1. Here, we need one more step. We're going to divide both sides by 2. That's the next layer that we're peeling off. So we have sine theta is equal to +1/2. That one was already pretty much good there. Now, these numbers are recognizable when it comes to sine. On the unit circle, sine can be connected to the numbers 0, positive or -1/2, positive or negative √2/2, positive or negative √3/2, positive or -1. So when you see those numbers, you are not touching a calculator. you will more than likely not even be allowed to have a calculator for those questions. Those are questions that you will and should be able to do using your knowledge of the unit circle. Again, you won't have a unit circle in front of you either. Where will you have it? In your brain. Now, how do you ask yourself this question? You ask yourself the sine of what angle or angles between 0 and 2 pi, the sine of which angles between 0 and 2 pi are equal to 1/2, or the y value of which ordered pairs on the unit circle equal 1/2. Without a unit circle, 1/2 is a little. It's a small amount. 1/2 is 0.5 as a decimal. Root 2 over 2 is about 0.7. Root 3 over 2 is about 0.87. Obviously, the other numbers are 1 and 0. So the smallest number that is greater than 0, or biggest number less than 0, whatever, the smallest number going above the x-axis, going up in the y direction, is 1/2. That's going to correspond to the angles closest to the x-axis. Which angles are those? Again, you shouldn't need to dig out a unit circle or look one up. You should know which angles these are. These two angles will be, so this is all continuing, theta equals pi over 6 and 5 pi over 6. If you were able to figure that out, go you, high five yourself, and let's continue. We're not done. Little arrow, sorry if it's, oh, I'm writing underneath that. I'm so sorry. I wasn't looking up. All right. That's what I get for trying to be creative, helpful. I don't know. There you go. So recap what I said over here. We were down to sine theta is equal to 1/2. Sine of what angle? Theta is an angle, a known angle, equals 1/2, or the y value on the unit circle. The y value of an ordered pair on the unit circle equals 1/2 for which angles? Again, 1/2 was the smallest amount, 0.5. Up a little bit, up a little bit. Sine is y, that's the y direction, up or down if it were negative. The two angles that correspond to that place are pi over 6 and 5 pi over 6. Pi over 6 is here in quadrant 1, and 5 pi over 6 is right there in quadrant 2. And that all goes to this. I'll highlight it with the same color in a moment. Here, same way, we ask ourselves the question, the sine of what angle is equal to +1? The y value of which ordered pair on the unit circle between 0 and 2 pi? The y value is 1 at what angle? Well, the y value, y-axis, is 1, the highest spot or the biggest number we can get. At what angle? You should know what this angle is. That is theta equals pi over 2. That's all we got for that one. 1 and -1, when it comes to sine and cosine, are the only places where you might have, well, will have one angle as an answer. And 0, 1/2, -1/2, root 2 over 2, negative root 2 over 2, or positive or negative root 3 over 2 are the places that you will have two answers, okay? So just to color coordinate a little bit here, sine of theta equals 1/2 when theta equals pi over 6 and 5 pi over 6. Got those answers right there. And I don't know if this will be a mistake or not. I think you could see through this blue. That's fine. I always get nervous using the blue highlighter. And there's pi over 2. Now, on a multiple choice assignment, you might have to be careful. They may list the choices in order from least to greatest. So then you would have the choices listed pi over 6, pi over 2, 5 pi over 6. So don't, panic if you don't see them written in the order you have them written in. Sometimes I do like to leave them on my paper sort of grouped based on where they came from. But if I were ever asking you to type answers in somewhere, I would probably ask everyone to type them in order from least to greatest, just so there was some consistency and whatever program was grading the open-ended answers could have a set answer key and would be able to actually grade them. So I hope that you were able to understand this modeling, this example. The three angles that we found, pi over 6, 5 pi over 6, and pi over 2, are the only three angles such that the angles are between 0 and 2 pi that would satisfy this equation. That means that they would make this equation true. So this equation is not an identity in the sense that it is not true for any angle theta. That's what an identity is. It's just always true. You can plug any angle in, it'll work. Here in an equation, our job is to figure out which angles would make this true. And there's not an unlimited number. Well, between 0 and 2 pi, there aren't an unlimited number of angles. We have three. If this did not have that interval given to us, we would basically have to describe pi over 6 and every angle coterminal to it, 5 pi over 6 and every angle coterminal to it, and pi over 2, as well as every angle coterminal to pi over 2, which means they terminate in the same place, overlap, okay? But we will discuss that more in the future. Hope you understood this example. If you did, for your own inventory, give it a thumbs up. If not, if you're like, what planet are you from? I don't understand. Put a thumbs down. And like I've said in the past, I will use that to kind of steer me into what kind of examples you need more of. Okay? So good luck with this one. Good luck with more like these, and good luck with the next type of example. All right? Bye.